Alright class, we are doing the last note sheet, but we're going to do half of it today and then the last problem the next day, so I'll split it into two videos. Today we're talking about complex zeros. Remember, complex means that it includes a real part and an imaginary part. And since we get the imaginary part from the quadratic formula, or it's basically taking the square root of a negative number. Remember, when you take the square root, you also get plus or minus. So basically what I'm telling you is that complex numbers come in pairs, where the imaginary part could be a plus or a minus. So knowing that, we can always find the last zero. If I tell you, for example, in number 1, I have 3 zeros, and 2 of them are 4 and then 3 plus I. What is the missing zero? Well, this is an imaginary piece, which means there has to be its conjugate, which would be its pair. And so we would say it's just 3 minus I is the missing zero. You can use that information to help you with the other problems, because sometimes you need 2 zeros to synthetically divide and things like that. So now this says form a polynomial in factored form with degree 4 and zeros of I and 1 plus 2I. So if this is an I, we also know we have a negative I. And if this is a 1 plus 2I, that means we also have a 1 minus 2I. Now, you guys know that if I said x equals 4, that comes from the factor x minus 4, the opposite. So we can do the same thing here with our i's. F of x is equal to x minus I, x minus a negative I, x minus 1 plus 2I, and x minus 1 minus 2I. So there we go. Now we have to FOIL it. Now what I would say is FOIL the pairs. So FOIL this piece and FOIL this piece. And actually, you know what? We should probably simplify this a little bit more just to make it easier for the foiling part. So f of x is equal to x minus I and x plus I. This one over here will be x minus 1 minus 2I, x minus 1 plus 2I. Okay, now we can start multiplying. So it's like foiling from before, distributing. X times x is x squared. You get minus xi, or ix, plus ix, minus I squared. This one becomes, and if you write everything out, take the first piece and multiply it to all 3 pieces. So we get x times x is x squared, x times negative 1 is a minus x, x times a 2i is a positive 2ix. Then we take this one, negative 1, and multiply it to all 3 things. So that's a minus x plus 1 minus 2i. Finally, we take the last piece and multiply it to everything, and we get a minus 2ix plus 2i minus 4. One second. Alright, 4i squared. Alright, so there we go. Now, some things to note. If I is equal to the square root of negative 1, I squared is just negative 1. So whenever you see an I squared, basically all you're doing is switching the sign of that thing. So in this piece right here, first of all, notice how these cancel. And we're left with x squared, and then it's minus an I squared. So minus a negative 1 becomes plus 1. Over here we have our x squared. Let's cancel out what cancels out. We have a plus 2ix minus 2ix. Minus 2i plus 2i. Okay. So now for the x's, we have a minus x and a minus x, so that's minus 2x. For the numbers, we have a 1 and a minus 4i squared. This becomes a positive 4 because it switches the sign. The I squared goes away and switches the sign because you're multiplying by negative 1. So we have 4 plus 1 is 5. So that is your final answer in factored form. This would be the function that all those zeros come from. And you can check that by setting this equal to 0 and solving, and setting this equal to 0 and using quadratic formula. And you should get all these answers back. So we just put it back into a polynomial in factored form. Okay, now we're going to do what we did before. For example, it says given that -5 is a 0 of this polynomial, find the remaining zeros algebraically. So again, this is going back to our synthetic division. If I ever give you a 0, that's basically telling you use that to synthetically divide. So we do that. We get 1 times -5 is -5. You add down and you get an 8. 8 times -5 is -40. Add down, you get a 17. Times -5 is -85, which gives us our 0. Okay, so what we ended up with here is the factor x plus 5, because we divided by a -5. And what's left is the x squared, 8x, and 17. Now, the two numbers that multiply to 17 are just 1 and 17, but there's no way we can add to 8 here. So, this is not factorable. So that means we have to use our favorite thing, the quadratic formula. So let's do that over here. X equals opposite b. Plus or minus the square root of 8 squared, b squared, minus 4 times 1 times 17, all over 2 times a. We do that and we get -8 plus or minus. This is 64 and this is 68, so we get the root of -4 all over 2. Again, do not cancel the 2 yet. You cannot cancel this 2 until there's a 2 in front of the root, or there's a 2 outside of the root. So we get -8 plus or minus, and then root -4 is 2i, if you remember from algebra 2, over 2. Now you can divide everything by 2, and your final answer is that the remaining zeros are -4 plus or minus I. And again, those are two zeros because you get -4 plus I and -4 minus I. I just put it as one big thing. Now, sometimes I give you the complex zero, like number 4. Given that 2i is a 0, find the remaining zeros algebraically. Well, guess what? First of all, if 2i is a 0, I'm going to just put a little box over here. The remaining zeros is what I'm looking for. You should already know one of the remaining zeros because i's come in pairs. So, this means that -2i is also a 0 to the problem. So here, you can use synthetic division for imaginaries as well. So we're going to do 2i and then do our synthetic division. Be careful though. Make sure you have zeros in for the x cubed term and the x term. So this is how synthetic division works with imaginary numbers. Same as before. Bring the 1 down. 1 times 2i is 2i. 0 plus 2i is 2i. 2i times 2i is a 4i squared. Remember, that changes the sign then. 2i times 2i is 4i squared, which is a -4. Bring this down, and you get a 9. 9 times 2i is 18i. Bring that down, because that's plus 0 is 18i. 18 times 2 is 36, but then it's I squared, so it becomes a -36, which is good because it shows us that that's a 0. Now you might be thinking, well, how do I write that as like x squared, x cubed? You know, you don't. With doing synthetic division with imaginaries, you have to do the other one as well. So since we use 2i, now we're going to use its pair. So we do it again. 1 times -2i is -2i. Well, look at that. We get a 0. 0 times -2i is 0. So we add down and we get a 9. 9 times -2i is a -18i, which means that those go away and we're left with 0. And now look at what we're left with. So we're left with this right now. And then we just ended up with, so we need to solve this. So if you solve that piece, we get x squared plus 9 equals 0. X squared equals -9. x is equal to plus or minus root negative 9. So that means my final remaining zeros that I'll put up here are 3i and negative 3i. Because that's what you get. Square root of negative 9 is 3i. You get plus or minus. So again, you can use synthetic division with imaginaries. And actually, we're going to do one with a more complex problem, but that's going to be on the next video. But we're going to finish this note sheet on the next video. Alright, but that is what we're going to do for Friday. Well, I guess it might not be Friday. We'll see. Talk to you later.